And we're going to put in parentheses a scale drawing today. Scale drawings are types of proportional relationships. When you're given a scale drawing problem, you're going to identify the scale and use it to find the missing value. Key note, you always want to set your scale up so the units are matching. Just like when we would do some unit rate problems, scavenger hunts have popped up on warm-ups, not in a lesson for you guys, but we always match units top to bottom. Read number 1 for me, please. Annalise, a scale. Draw yourself a little miniature house. That's the White House, and I guess people in Japan like to go watch a tiny figure of the White House, just very miniature, in the World Square. They go over and they look at it and they go, oh, look at that cute little house, like an ant could live in it. Maybe there's a presidential ant. I don't know why, but it is actually in the real world, it is drawn to scale. However, in America, we have this giant house called the White House that ants don't live in, but an actual president lives in. So here's the real White House. There you go. We'll put Mr. President. I don't know why he's wearing a top hat. Don't ask me. Here's the ant. We'll make the ant wear a top hat too. Sure. So what's happening is you're blowing up this giant, this little tiny figure, and you're making it the White House, or you're shrinking the White House down. It's kind of like, have you guys seen the movie Despicable Me? And he says like, I stole the Eiffel Tower or the Statue of Liberty, and it's like, well, wait, which one is it? He steals the
miniature one from Las Vegas.
Yes, he steals the Statue of Liberty, but it's the tiny one in Las Vegas. So essentially what we're doing is we're just like shrinking little things down, but they are to scale. So you're going to try to figure this out. What is the actual height of the model? What's the actual height of this tiny little White House? Start out with your scale. And the scale they give you is right here. Box the scale. 1 centimeter to 25. Write that underneath scale. Make sure your units are labeled. That's going to be very important. Then we're going to write the other side. They give us 100 feet for the White House. That's the actual height of it. Where would I write 100 feet? I want it to match, Tennyson, if you have a question, hand up. I want it to match this. Peyton, where would it go? It'd go on the bottom of the fraction. Since feet is on the bottom, match feet also with the other one. Then we're missing this top part. This is the actual, x is the actual, it's the model height. Cool. Once you set this up, these problems are very much more about setting up the problem than actually doing a lot of tricky math. I can look at this setup and get my answer fairly easily. If I go from the number to what I'm looking for, always draw your arrow so you're looking at the answer that you're trying to find. I'm drawing the arrow to look at x. 25 times what would be 100? 25 times 4 would be 100. So that means on top, 1 times 4 is 4. This little guy is 4 centimeters tall. What a cute little house. Has anybody been to Japan? No. Did you go to Tobu World Square?
No, I'm not talking about that.
Oh, okay. Question.
Saying if it's 1 centimeter every 25 feet, wouldn't it be well, obviously it's for every 100,
Mhm.
but would that be even, or is that just a coincidence? Since it's like 1 every 25, and 25 goes into 100 4 times.
It is not a coincidence. That is how we do scale problems. Good point. Yeah. Thanks for clarifying that again. You have to have the same number top to bottom. So if you did 25 times 4, you have to do 1 times 4. Okay, that's how scales work, and 4 centimeters is a miniature little house. How cute. I kind of want to look this up at the end of the class. Someone remind me. Number 2, read it for me, please. Milo, a museum. It should say model. Keep going. Okay, underline actual height, that's what you're looking for. Start out with your scale. What's the scale for this one, Liliana?
Scale?
Yeah.
100 to 1 centimeter.
Okay. What did I forget to write? If I'm going really fast, because I think I got this, Alexis. Jada, you need something, let me help you out. Brady, what did I forget?
Your centimeters and feet.
Yeah, we gotta label the units. That's one of the most important parts. Okay. And go to what they give you for the other sides. 5 centimeters. Where do I write that number, Jillian? Yeah, it needs to match the units on the top. So I'm going to look at this thing and I'm looking for the x. The x is going to be the actual height of Dino. And how do I get there? Well, 1 times what is 5, whole class? 5. So on the bottom, it's logical I could do 10 times 5 to get the height of this dino. 10 times 5 is, Claire? 50 feet. This dino is fairly large. That's your answer for these problems. They'll get a little trickier Monday, so make sure your units are set up. Yeah. 50 feet is your answer. 5 centimeters is what they give you. So the answer will always be the thing next to x, the thing that you're looking for. Last example, raise your hand if you ever held a map before. Hands down, any parents or people actually use a map, like not like on a phone, but like a paper map. You guys used some maps before? How cool. So 10 years ago, or yeah, about 10 years ago, right like before the cusp of the phones and all the map, like Google Map stuff came out, my parents would always go on a trip with us, and we'd load in the car, and it'd usually be like 9 p.m. because they took forever to pack, and I'd be sitting in the car waiting from like noon to 9 p.m. just waiting for them to get in the car finally to leave. So we usually roll out, and the first thing they do is they'd get like their flashlights out because it's pitch black out when we left. They'd take the crinkled up map out from the side door, and they'd roll it out of the like dashboard, and they'd look for where we're going. And we'd end up like taking probably double the amount of time to get somewhere. If it took us 2 hours, it would take us really 4. Because they would like end up going this way on the map, and they'll be like, oh wait, we're going towards Washington, we really want to go towards LA, and then they turn around and it was a mess. Maps use this thing called scale models, and that's like the stereotype of what you actually use this in the real world. Yes? Yeah. Good question. So look back at 1. Sometimes your answer will be at the top. Sometimes your answer will be at the bottom. It just depends on what you're trying to find. The top here is the model. It's in centimeters, right? The bottom is the actual size. In the top, they wanted us to find that model sized. On number 2, they wanted us to find the actual real life size. Good clarifications. So a map is what we're going to deal with for some of these problems. It's a real life example of a scale drawing. If you're traveling from New York to LA to visit Mickey Mouse and his friends at Disneyland, given a map scale of 1 inch to 400 miles, find the actual distance you're traveling if they are 7 inches apart. What's the scale for this one, Milo? Start with that. Cool. Okay. And what information do they give us? They give us 7 inches apart. Do I put 7 inches on the top or the bottom Oshu? Yeah, just to match the unit on the top. So that means X is what I'm looking for. I'm looking for the actual distance. My answer should be the one on the bottom. Draw your arrow and point to the X, because that's the way I'm going. Draw your arrow and point to the 7. 1 times what is 7, Kira Bentley? 1 times what would be 7? So what do I do on the bottom, Kira? You got it. That should be my answer. Claire, do you have it, or do you have a question? What's 400 times 7? Good. Make sure you label it. It is 2,800 miles is the actual distance. You got 4 problems with the partner in the next 4 minutes. Things I'm looking for, these can get pretty monotonous, but I need you to practice the setup because they will get trickier Monday. You need to write scale on your paper. You need to show me what the scale is with your units. And then you need to make sure your units match. Take out your clocks, 30 seconds, our pencils are going to be writing. Clock partners are starting right now. If you don't have your clock, raise your hands.
Oh, yeah.
If you don't have a clock or your partner is gone, you're going to come see me. You don't just choose. I will choose for you. Go to number, who haven't you done yet? You have to have practice for that. Points number 10, even if you've done that. Make sure you're moving to that number. Don't just choose randomly. You'll get a bench collection. Go, 30 seconds. Come see me if you don't have a 10. Or if your 10's gone. 30 seconds, pencils around paper. You don't have a 10?
No.
Who's your 10? Cool. Alright, Brady, you're going to join a team of 2 to make a team of 3. So go over to Milo and Oshu. You can just sit right in front of them and turn. So 10 o'clock, right, Milo?
My partner's gone.
Who's your partner? Okay. For 10 o'clock, write Jersey and Tennyson. And you'll work with the teacher today. Brady, are you moving?
Yeah.
Okay.